Is a thing called Dalton's law of partial pressures. I know the first time I heard that, I went, oh my goodness, that's so long and I have no idea what any of these words mean. It's going to be really horrible. And it's not. It's actually quite simple. You need to be able to add and subtract. No multiplying, no dividing. First of all, let's take a look at a couple of concepts we haven't looked at yet so we can see why Dalton's law might be useful. The first thing we're going to look at is something called the vapor pressure of water. So I have some water in a container. Notice the ripples, like it's a wave, like we're at the beach. And the container is sealed, so no water can get out. And what will happen is water will start evaporating. Those are the little arrows. And after a while, this airspace above the water is full of water vapor, and the water will start condensing as well. As the water vapor molecules are moving around this space that's filled with air, they are also going to put some pressure on the surface of the water. That pressure is called the vapor pressure of water. The hotter the water gets, the higher the vapor pressure becomes as more and more water molecules evaporate, go into the gas state, are flying around this top space filled with air, and put pressure on the surface of the water, not just the surface of the container. The other thing you need to know about is what's called collecting gas over water. So we have the same setup here. We've got water, we have water vapor, the little arrows, but we have a reaction off to the side and it makes a gaseous product. The gaseous product runs through a tube to an opening in the bottom of what's called a gas collection flask, and it will bubble up through the water. As you make more of it, the water can escape out. It's in another larger vessel, but you're collecting your product above the water, and you have a mixture of your product and water vapor. That's where Dalton's law comes in handy, because Dalton's law says that the total pressure, P total, is going to equal pressure, say, of the gas you want to collect plus the pressure of water vapor in this situation. So if you happen to look up the vapor pressure of water at a particular temperature, you would have P total minus P water equals the pressure of the gas you are looking for. We'll do one problem like that. But the formal statement of Dalton's law is just that P total equals pressure 1 plus pressure 2 plus pressure 3, ... as many pressures as you have. So if you had a mixture of 5 gases in a container, each pressure is independent of the other. If you know 4 of the 5 gas pressures, you can solve for the 5th. To do the pressure of something over water, suppose we have a situation where we have oxygen collected over water at 20 degrees C. The vapor pressure of water at 20 degrees C is 17.5 millimeters of mercury, or torr. Remember those units? And the pressure in the collection bottle is 730 torr. Okay, that's P total. I want to find the pressure of oxygen. So I have P total equals P oxygen plus P water. That's given to me. This is P water right here. P total is given to me. So P total minus P water equals the pressure of oxygen. P total is 730 torr. pressure of water is 17.5 torr. And if I subtract those two, I get 712.5 torr. Other simpler problems, which you'll see in your book, may have a total pressure of 760 torr if you have 100 torr of oxygen, 500 torr of nitrogen, and some unknown number of torr of CO2, and you would just subtract to get that third one. So we're about done with Dalton.